Possible causes of sudden ballast failure include a surge in electrical current, where a sudden voltage spike can damage ballast, so check if there were any recent power fluctuations or surges. Another cause may be faulty ballast, where ballast components can deteriorate over time, leading to failure, so consider the age and condition of the ballasts. Electrical arcing is another possible cause, where arcing within the ballast or wiring can cause damage and blow fuses. Inspect for any signs of arcing, such as burn marks or melted insulation. Resonance can also cause failure, where excessive vibration can resonate within light poles, causing stress on components. If the hum was particularly loud, this could be a contributing factor. Environmental factors such as extreme temperatures, moisture, or corrosion can damage ballast, so check if there were any recent weather events or environmental changes. Less common causes include loose connections, faulty relays, or problems with the light fixtures themselves. Recommended troubleshooting steps include: firstly, inspect all wires and connections. Check for any loose or damaged wires, loose terminals, or corrosion. Tighten any loose connections and replace any damaged components. Secondly, test the ballast with the voltmeter. Measure the voltage at the ballast terminals to ensure it is within the specified range. Thirdly, inspect the light fixtures. Make sure the fixtures are making good contact with the ballast and are not loose or damaged. Fourthly, check the electrical system. Verify that the circuit breaker and wiring are functioning properly. Fifthly, inspect the light pole. Look for any signs of structural damage, rust, or corrosion that may have contributed to resonance. Finally, contact the manufacturer. Consult with the manufacturer of the lighting system for their input and possible troubleshooting assistance. Before replacing any ballast, it is crucial to identify and rectify the underlying cause of failure to prevent recurrence. Consider these points when diagnosing the light pole issue. Firstly, determine if there was a surge in electrical current. A sudden voltage spike can damage ballasts. Investigate whether there were any recent power fluctuations or surges in the area. Use a power quality analyzer to monitor the incoming voltage and identify any transient events or voltage irregularities. Check the historical voltage data from the utility company, if available, to see if there were any recorded incidents of voltage spikes or surges. Install surge protection devices to mitigate the impact of future surges on the ballasts and other electrical equipment. Secondly, evaluate if there were faulty ballasts. Ballast components can deteriorate over time, leading to failure. Evaluate the age and condition of the ballast in the light pole. Check the manufacturer's specifications for the expected lifespan of the ballasts. If the ballasts are nearing or have exceeded their expected lifespan, consider replacing them proactively. Examine the ballasts for any signs of physical damage, such as cracks, bulges, or leaks. Use a multimeter to test the ballast input and output voltages to verify if they are within the specified range. Compare the readings with the manufacturer's datasheet to determine if the ballast is functioning correctly. Thirdly, examine if there was electrical arcing. Arcing within the ballast or wiring can cause damage and blow fuses. Thoroughly inspect the ballast housing and wiring for any signs of arcing, such as burn marks, melted insulation, or carbon deposits. Pay close attention to the connections and terminals, as these are common areas for arcing to occur. Use a thermal imaging camera to scan the ballast and wiring for hotspots, which can indicate areas of arcing or overheating. If arcing is suspected, carefully disassemble the ballast and examine the internal components for signs of damage. Replace any damaged wiring, connectors, or ballast to prevent further arcing. Fourthly, consider resonance as a factor. Excessive vibration can resonate within light poles, causing stress on components. If the hum was particularly loud, this could be a contributing factor. Inspect the light pole for any signs of structural damage, such as cracks, rust, or corrosion. Check the foundation of the light pole to ensure it is stable and not sinking or tilting. Use a vibration meter to measure the amplitude and frequency of the vibrations in the light pole. Compare the readings with the manufacturer's specifications to determine if the vibrations are within acceptable limits. If excessive vibrations are detected, consider adding vibration dampening materials or devices to the light pole to reduce the stress on the components. Fifthly, analyze environmental factors. Extreme temperatures, moisture, or corrosion can damage ballasts. Check if there were any recent weather events or environmental changes that could have contributed to the ballast failure. Inspect the ballast housing for any signs of moisture ingress, such as water stains or corrosion. Ensure that the ballast housing is properly sealed to prevent moisture from entering. If the light pole is located in a corrosive environment, consider using corrosion-resistant materials for the ballasts and wiring. Use a temperature sensor to monitor the temperature inside the ballast housing. Ensure that the temperature remains within the manufacturer's specified operating range. Sixthly, check for other issues such as loose connections, faulty relays, or problems with the light fixtures themselves. Inspect all wiring connections for tightness and corrosion. Ensure that all connectors are properly seated and secured. Use a multimeter to test the continuity of the wiring and identify any open circuits or shorts. Check the relays and switches associated with the lighting system for proper operation. Replace any faulty relays or switches. Inspect the light fixtures for any signs of damage or wear. Ensure that the light fixtures are properly mounted and grounded. Furthermore, perform these additional troubleshooting steps. Firstly, inspect all wires and connections. Check for any loose or damaged wires, loose terminals, or corrosion. Tighten any loose connections and replace any damaged components. Use a wire brush or terminal cleaner to remove any corrosion from the connections. Apply a dielectric grease to the connections to prevent future corrosion. Use a torque wrench to tighten the connections to the manufacturer's specified torque. Secondly, test the ballast with a voltmeter. Measure the voltage at the ballast terminals to ensure it is within the specified range. Refer to the ballast manufacturer's datasheet for the correct voltage range. If the voltage is outside the specified range, investigate the cause of the voltage drop or surge. Check the wiring and circuit breaker for any issues. Thirdly, inspect the light fixtures. Make sure the fixtures are making good contact with the ballast and are not loose or damaged. Ensure that the light fixtures are properly mounted and aligned. Check the light sockets for any signs of corrosion or damage. Replace any damaged light sockets. Fourthly, check the electrical system. Verify that the circuit breaker and wiring are functioning properly. Use a multimeter to test the circuit breaker for continuity and proper operation. Check the wiring for any signs of damage such as cuts, abrasions, or overheating. Replace any damaged wiring. Ensure that the circuit breaker is properly sized for the lighting load. Fifthly, inspect the light pole. Look for any signs of structural damage, rust, or corrosion that may have contributed to resonance. Check the light pole for any cracks, dents, or bends. Inspect the base of the light pole for any signs of rust or corrosion. Repair or replace any damaged sections of the light pole. Consider applying a protective coating to the light pole to prevent future corrosion. Sixthly, contact the manufacturer. Consult with the manufacturer of the lighting system for their input and possible troubleshooting assistance. Provide the manufacturer with as much information as possible about the issue, including the make and model of the ballast, the date of installation, and any recent events that may have contributed to the failure. Follow the manufacturer's recommendations for troubleshooting and repair. Request any technical documentation or service bulletins that may be available for the lighting system. Remember, before replacing any ballast, it is crucial to identify and rectify the underlying cause of failure to prevent recurrence. If the 30A 480 volts breaker never tripped but the fuses in the ballast housing did blow, it suggests that the overcurrent was not high enough or sustained long enough to trip the main breaker, but it was sufficient to blow the smaller fuses in the ballast housing. This could indicate a localized issue within the ballast or its immediate wiring. Since all of the wires checked out fine and no visible arcs or shorts were found, it is possible that the ballast itself experienced an internal failure that caused the fuses to blow. Internal failures can occur due to component aging, manufacturing defects, or voltage stress. If resonance was observed before the failure, it is possible that the vibrations contributed to the internal damage of the ballast. The repeated stress from the vibrations could have weakened the components over time, leading to failure. When replacing the ballast, consider using high-quality ballasts that are designed to withstand vibration and voltage fluctuations. Also, ensure that the new ballasts are properly installed and grounded. Before replacing the ballasts, double-check the voltage at the pole to make sure there is 480 volts and no voltage drop. Voltage drop can cause issues with ballasts. The fuses in the ballast housing are designed to protect the ballast from overcurrent conditions. If the fuse is blue, it indicates that there was an excessive current flowing through the ballast. This could be caused by a short circuit, an overload, or a failure of the ballast components. Check the fuse rating to make sure it matches the specifications for the ballast. If the fuse rating is too high, it may not provide adequate protection for the ballast. After replacing the ballast, monitor the light pole for any signs of recurrence, such as humming, popping, or flickering. If any of these symptoms occur, investigate the issue immediately to prevent further damage. Consider implementing a preventative maintenance program for the lighting system, which includes regular inspections of the light poles, ballast, and wiring. This can help identify potential problems before they lead to failures. Document all maintenance activities and repairs performed on the lighting system. This will help track the performance of the system and identify any trends or patterns that may indicate underlying issues. Consult with a qualified electrician or lighting specialist for assistance with troubleshooting and repairing the lighting system. They will have the expertise and equipment necessary to diagnose and resolve complex electrical issues.